don't need to invoke the word force. You're not talking about forces there, but it is still a force. It's just that it's the way he talks about it.
It's
All right,
a
can I
force,
say
but
something
it's not
now?
a force. Do you see the
Can I
contradiction?
say something now?
No, but here's the example I keep giving you guys, and I'll just give it to you real quick. If I ask you, is Robin Williams a comedic actor? You're going to say yes. Maybe if you think of like one of his comedy films, like Mork and Mindy. But if you think about Good Will Hunting first, maybe you'll say no, he's a dramatic actor. He is both a comedic actor and he is not a comedic actor. Hold on, let me finish. No, let me finish. He is both a comedic actor and not a comedic actor, depending upon the paradigm with which you look at him. Same thing happens here. It is a force if you look at it to a paradigm that is using force as a reasonable way of measuring things. It's not a force if you look at it to the Einsteinian paradigm. This should not be a hard concept for you to understand.
Okay. So let me rebuttal that very easily. When you said Robin Williams is some sort of an actor and then the other sort of an actor, those two sorts are not opposites. When you claim that gravity is a force and when you claim that it's not,
what I said was he's a comedic actor and he's not a comedic actor. How is that not an opposite?
Can I have a turn now?
Sure.
Right, can I say something now?
Yeah.
Okay, good. All right. So what you said before about people colloquially use the word the force of gravity. And they use that word because it's a simple way of describing things, the amount of force that's applied because of gravity. So that's a simplified way in our normal everyday language. That's what we mean when we say the force of gravity. No one's going to bother to take this all the way back to to discussing general relativity. Every time they need to discuss, they need to design a beam that goes across a 20-meter ceiling. They don't need to do that.
That's not what we're talking about.
They'll just talk about how much is the force of gravity acting on that beam, and therefore how thick do I need to make this beam? This is how it works.
Okay.
The stupidity that comes from flat Earth is that they think that if you can discredit this gravity, then the problem will just go away and the Earth will turn flat. That's the stupidity of it all.
Okay, that wasn't my claim at all in the first place. The second thing is that when you cannot, and I'm not talking about you per se, of course, when you cannot point out what is gravity, you have theories at best.
Well, theories are a good thing to have. When you say at best, that's about as good as it gets.
Drop a brick on your bloody foot and then tell me it's a theory.
You can have a theory that you are the, I don't know, most powerful.
Drop a brick on your foot and then tell me it's a theory.
Phil, relax, dude, relax, okay? We're talking about scientific theories here, right? We're talking about scientific theories. So a scientific theory is about as confident as we can be in anything.
What's up?
Very confused here.
Because you're a flat
Very
earther.
confused.
Sorry,
we got people talking about whether gravity is or is not a force. And in the context of this discussion, I don't know what, let's say somebody says, no, gravity's not a force. What do you mean by force? Define force. Tell me the force that it is not. What is the force?
I like that.
It's not the force that makes shit go down.
That's a good question.
He's asking what's up. He's asking what's up.
Oh, you're asking me? What is the force?
Yeah, that the gravity is
the force. The force that this is
other
not.
Things.
Say again.
It's not a scientific term, but anything that makes another object or anything to move or to act differently.
He's using my definition.
Out
of its causes an acceleration.
Equilibrium, for example, that's maybe a better phrasing.
So then how is gravity not a force then?
Because you don't even know what gravity is in the first place.
But
that's
it's the thing that causes things to move. It's the thing that causes things to accelerate towards the ground. Hold on.
The thing that causes
things to accelerate towards the ground. So if it does that, then we know it's a force, right?
What's up? You don't know what it is. How do you know what it is?
What's up? You don't know what
it is. Anything that causes the movement. You said that anything that causes movement is a force. And so we see movement, we can bet there's a force there, right?
And how do you know it's not something else if you cannot even
You
point
just
out
defined it that way.
gravity?
You gave us the
Oh,
definition.
God.
Because remember, the word gravity is that force that's causing those things to fall towards the ground. So whenever we see the falling towards the ground phenomena, we're talking about gravity. That's the word we use for that force, whatever it is.
Whatever it is.
Yes, whatever it
You-
is. We have a ton of
Name
mysteries
is
about gravity
irrelevant.
still to figure out. We don't know lots about gravity, but we know it's there. We know that things do move towards the ground, accelerate towards it. We call that gravity.
Why
How
your
would you
brothers
define
are so
gravity,
hell-bent on the
Watson?
name?
How would you define
Yeah,
gravity? Watson?
Everything moves towards the ground, by the way.
I
Why?
think.
So
Hang on, I've got a good word for it. What's up? And every other flat earther should, instead of calling it gravity, should call it
Yeah, but I'm
being
not a flat
put,
earther, by the way.
being put out of unequilibrity.
okay, thank you, General.
How would you describe it? Gravity then? What's that? What would your description of it be?
By the way, that's what I said when I rephrased for the third time, that anything that makes another whatever, because we can say object, but that's not covering everything. The force is whatever makes another something to get out of its equilibrium.
Okay, what's
So,
up? So here's an experiment I'm going to film in the next couple of days.
So
I got a table.
all we see is the movement itself. That's what I wanted to point out.
Okay, so here's an example I'm going to film in the next couple of days. I've got a round table, right? It's on a lino floor, so it's real slippery. I've got a glass bottle that's got 1,000 mils of water in it, which means 1 kg plus the glass, give or take.
Okay.
Right, so what I'm going to do is I'm going to put a clamp with a release mechanism on the neck of that bottle, and then I'm going to remove the table from underneath the bottle, so there's nothing there. I haven't disturbed its equilibrium. It's in the exact same place, and if that bottle stays where it is after I release the mechanism, you guys win. If it falls to the floor, I win. What say you?
Oh my! What did you say? That you didn't do anything?
Don't ask him to repeat it.
No. Hang on. No, I will. The
That's not
bottle
what you said.
is
Oh,
in the
so you did
exact same
something.
place. No,
Great.
the bottle's in the exact same place. I haven't touched the bottle. I've removed the table that it's sitting on, because if what you guys are saying is that because I haven't moved the equilibrium that it's in, that's all that matters. So it should
You
stay
have, Jezza.
exactly where it is.
That
By moving the
system,
table,
that
you've
system,
done that, Jezza.
That system that
No,
you are
I haven't.
describing right now.
I haven't was.
That system
no.
that you are describing right now contains the table also.
They'll just say the bottle's found its equilibrium on the table. Once you remove the table, it's got to find
Of
its new
course.
equilibrium.
Of course they're going to say that, but we're talking about the
So,
bottle.
don't
So
worry
they can't
about it.
say that the bottle's attached to the table.
It rests upon it. What the fuck?
Now, to do it a little
Holy
more
cow.
simple.
But
No. Hey,
no, sorry, Sort. You go ahead.
to do it a little more simple.
Don't say
Gravity.
A.
The word gravity defines the reason things fall and have weight. It has always been observed as acceleration.
Who didn't know that was coming? Anybody?
Yeah.
I didn't even hear what he said.
What about
I said it in my head
balloons?
before he even said it.
What did he say?
Gravity is always observed as an acceleration.
Oh, okay.
And that acceleration
So
remains
what
observed.
about balloons?
What about them?
What's up? What's up? Why are you still
Is it
arguing
going
about
down?
this? What's up? You
Balloons are going
agreed that
down.
a force is anything that causes an acceleration, no?
Yes.
No,
I thought you defined it.
No, he
That's
said
what
it's,
he said.
I said
he said it's
Not
a force
most
water. Some,
moving
I think he
out
said it's
from its
off-
equilibrium.
Yeah.
That's what I said.
Yeah, but if it
And
accelerates,
and
it's
how?
right? But
Let
if it's
other
accelerating-
people tell us what you said, because I can't understand you. Let English speakers say it.
If it what you said was that a
Oh
force
my
is
fuck.
something that moves something
saying
out
it's
of
a-
equilibrium. Jesus Christ, guys.
force-
It's something that
It
it's
was
something that moves
something out of
hard
equilibrium.
so far that you cannot understand me. Like everybody can, besides you.
I
He
can
said it's a
understand.
Yeah, okay. Everyone talk at once.
Whatever it was, that was you doing it too.
I know.
All right, so what's up? What is your dispute with anything that causes an acceleration?
What is my dispute against that? That I didn't say that.
Yes,
And
but
you're
that
trying
would
to
be
say
out of
that
equilibrium, right?
I didn't.
That would be out of equilibrium, right?
That would be one thing that could this be described as out of equilibrium. Yeah.
Okay, so if something is accelerating, we know it's moving out of equilibrium, which means by your definition, there's a force.
There is a force, but how do you know it's gravity?
That's what we call it. We gave it that name after we saw the observation of motion.
So again,
okay, I'm done with this
it's
slime
gravity.
ball.
Then what about
Dude, what is
balloons?
gravity?
It's not a
What-
slime ball. It's just retarded.
What is your version of gravity? You're just going around in circles, mate.
Why
took
does a
off the name
balloon go
gravity?
up at all?
Force.
So, from your point of view, the net force doesn't exist.
No, I'm asking. Why
So,
does a balloon?
That's why I'm asking
at
you.
all
In,
go
in,
up?
in your point of view, net force doesn't exist. You know what is a net force?
Yeah, sure. Is the sum of the vectors of every force that is acting upon something.
Okay, here you go, your answer.
What do you mean? Here you go, your answer.
That's why the balloons are floating.
Because of what?
So if you put every force that are applied to that balloon, you're gonna have a float.
We haven't established that gravity is a force in the first place, so
I'm talking about all the forces.
okay.
Gravity is a force. You're saying that you need a force
Okay,
for
you said
objects to
nothing.
move down. So then there is a force, and we just call it gravity. The name is irrelevant. Scrap the
What
gravity,
up?
just say there's a force.
What up? Just real quick.
Uh-huh.
You know that hydrogen and helium are lighter than air, and they float. So you think that gravity is not a force because they float. Remove the air, they fucking sink to the ground. So eat shit. I mean, eat silage.
Dude, there's just no need to add that stuff. There's no need.
We
There's no
are
need.
into insult land right now. Great.
I'm sorry. Eat hay.
Just don't do it. Just don't do it. It's not that hard.
What's up? Can I ask a quick question?
Sure.
Yeah, when you have like let's say an ice cube, when it's floating on water, is it in equilibrium and there's no forces acting on it?
But if it stands in a very, equilibrium way, then of course, but it doesn't. It doesn't happen.
Okay, so if I have a glass of water on a scale and I put some ice on there, the weight wouldn't go up with the ice being poured in.
What do you mean by the weight wouldn't go up? Which weight?
The weight of the whole system, the glass and the water and the ice.
The volume
Because the
of
ice
water.
is in an equilibrium.
So now you're talking about a bottle that has some ice in it and some water, okay?
No,
and that
just
rests
let's say a
upon
bucket.
something, right?
Let's say a bucket on a scale with water in it. And it weighs 1 kilo, let's say. There's a little under a liter of water and a bucket, plastic bucket. And I throw in a liter of ice. Does the weight go up? Because you're saying that it doesn't go up because there is no force acting on the ice because it's in a equilibrium.
No, I have not said that
Great
at
example.
all. I said that we only can observe certain things, and then you guys come along and some, way bigger brains, and then tell you that there is such a force as gravity, and that's what's causing the acceleration, for example.
No, I asked about your equilibrium theory that you have. I didn't say gravity. I said nothing.
I haven't said anything like that.
You have said disequilibrium. And things organize.
That's
and they
not
go
what
to...
I said. You're twisting what I said.
Okay. Okay, so you don't ascribe to relative density and disequilibrium thing.
Oh my fuck.
Great
Well,
example.
I heard you say it. But...
It's not rocket science.
You heard me say equilibrium. That's great.
Yeah.
That's great. That's great.
Sure. So why do objects move up and down?
I asked another guy. It was Prof. Phil, by the way, a few minutes ago. Well, not a few, like 20 minutes ago. how do surveyors measure the circumference of the Earth?
So you have to skip the topic.
Could anybody tell it?
Another point to discuss.
Yeah.
So
How
you
do
don't
they actually carry out?
so
the
you don't
measuring of the
understand
circumference of the
gravity.
Earth?
You don't understand gravity, but you want to understand the bending of light.
No. I'm not talking about bending of light. I'm talking about theodolite use for
So
measuring the
that's why I'm.
circumference of the
That's
Earth.
mate. In our observations, it's an atmosphere. Yeah, that atmosphere.
Wh-
One
What's
second.
the-
That atmosphere, it's applicable to our observations and our measurements. So, what's your point here? That's why I have said to you, you don't understand gravity, but you want to go with the bending of light.
I understood gravity way more than you because you are stuck in the times when Newton said that gravity is
No.
a force. They are not saying that anymore.
Yeah, they are. They
So-
say it all the time. What do you think? Go look up what the 4 fundamental forces of the universe are and tell me if you don't think gravitational force will be on that list. They still call it a force. It's still a force. It depends on your paradigm.
Oh, it's a fucking force, all right. There's no
Oh
denying
my
it.
fuck.
It's true, dude.
No,
It's just
they
there's
do not say that anymore.
They do. Go look at any modern physics and you'll see. I can find you dozens and dozens of them.
Well,
We
I'm
do this all the
sure
time when people
anybody
say that.
listening in right now will understand what I just said. The
Of course,
difference
you
between
think-
the Newtonian gravity
Yeah.
and the Einsteinian gravity.
Yes, but they're just different paradigms. So neither you remember that Newton is derivable from the field equation.
Of course, it's a paradox. That's why you guys have the confusion because you don't get
except for
it.
one
There's a
subsumes
huge
the other.
contradiction.
It's not a
There's no-
contradiction. Hold on. One subsumes the other. If you can get Newton from deriving out of the field equations, then how do they contradict each other?
Oh my fuck.
Well,
So
how do you
again,
explain that?
Theodolites. How do you use theodolites or
Well,
autologous?
what
which
about the
are
question I just asked you? If
obviously
you can
against it?
derive Newton from Einstein's field equations, how would you say that they are contradictory?
Oh my.
That's
Again,
a fair
see,
question,
one
don't you
theory
think?
says one thing and the other says a whole different
I'll say.
opposite.
Let me ask you the question one more time. Just listen to the question. If you could derive Newton's equations correctly out of Einstein's field equations, then in what way could you say they're
No,
contradictory?
you cannot.
Yes, you can.
cannot.
Absolutely, you can.
Oh.
So-
You
Ex-
absolutely can.
I don't know why you
show
think
me
you
them,
can't, but you
please.
can.
Explain in your
Just show
words
me them, please.
why Einstein is not deriving from Newton and why Newton is not deriving from Einstein. Explain
So you
some
have a
way.
positive claim that it cannot be it can be derived from Einsteinian, right? So
Yeah.
please show that to me
Yeah,
in some way.
Now, what's up? You're missing it if you're a flat earther, because the flat earthers, their
I'm
claim
not.
now is that Einsteinian gravity, mass attracts mass, is 100 years out the window, which is a complete load of horseshit, which one prominent flat earther has told them that thinks he's fucking God. I won't say any names. And now they're like, oh, fucking space and time. You can't fucking use that.
I asked you to show me. How do you derive the Newtonian gravity from the Einsteinian? Anyway, please, someone post something or tell me.
Mass attracting mass is perfectly feasible.
So it's not space-time that's bending, that's causes
No,
things to fall
that's
towards
what-
each other. It's not that.
That's what I was just saying. The flat earthers are saying that mass attracts mass was taken out 100 years ago, which is a complete load of horseshit. And now it's the bending of space and time, and it's too complicated for them to understand because the flat Earth is created by a real basic bitch. Because
That's not
everything's
what you're
fake.
saying. You're
make
just
the Earth
slandering
flat.
people right now. You're
Is it
literally
really all that
slandering
different,
people
or
right
is
now.
one just an explanation of how and why?
Again, you are literally just slandering people when you say
Is
something
one
like
just
that.
an explanation of
This
how and
group
why?
of people,
How and
this
why the
group
same
of
thing
people think
happens?
this way, and therefore they are stupid. That's what you said. Nothing else.
You're not. Fuck him. He's a drunken moron. Don't listen to him. Answer my
Oh,
question. How is it that Einstein is not just an explanation of how and why?
How is that? How and why? What?
Jesus.
The mass affecting space-time, causing that curvature that brings them together. How is that not just a more detailed description of how this force operates or what brings them together?
Because
Tell me
it
how,
doesn't claim
honestly.
anymore that gravity is a force. It doesn't claim it anymore. That's
Don't
why.
sit there twirling in your rhetoric. Answer the fucking question.
And I just answered.
He said because
It would be
Einstein.
easier if we were talking
DC's
about
ruined.
centrifugal force. It would be easier.
Just
No, he
keep
said
chasing him around all day. He's already fucked up. I don't know why you guys just take the win.
1 second, guys. He said because Einstein doesn't apply forces on the gravitational equation. That's his claim. It's not my claim. It's his claim.
Yeah, it's not about a force.
Force.
And from where did you took it, this thing? Did you done it the mathematics? Did you apply it in some way? Did you see the for example the Jupiter moons that are orbiting
That's a good
Jupiter,
question,
and
by the
you
way.
have been seeing that?
That's a great question because I heard that some guys, at least one of them, is having a YouTube channel in which he's doing the Cavendish experiment. I heard about
Yeah,
that. guy.
Biodual and Big Blue.
Yeah. Oh, it's two guys. Okay, great. So my question to them was, because I have been around for a long time now, well, quite
Yes, but
long enough.
you didn't
talk
ask
to them.
you didn't answer my
And,
question. From where did you derive it? From where did you derive it? Because Einstein didn't apply a force.
I'm answering. I'm right now
How?
answering. Listen to what I'm saying. So the Cavendish experiment is supposed to be one of the greatest evidences for gravity. The kind of gravity that describes gravity as a force that is in between two objects that have masses, right?
Yeah, what does the Cavendish say that it's the cause?
But the Cavendish, and whenever I saw a Cavendish experiment, it was only using any kind of metal as a weight and the mass. And I asked these guys, why don't you use something that is plastic or wooden or anything like that?
Because you need a
I have
lot
never
of mass
seen.
to see it happen.
So what? You use a bigger wood. So what?
You need
How
a
big?
lot of mass.
Okay,
You
okay. You
Because the
can use a
distances are
big
so
piece of
small.
wood.
No, mate.
Because gravity is such a small thing, you'll need a lot of mass. That's why you want to get as much mass as possible. That's why you find something that's got a lot of mass, like lead balls.
Okay, you use a bigger ball than a lead ball that is just made out of wood.
What?
What's the difference?
Yeah, it'll have to be as big as a country then, just about.
As a country,
I'm joking, but
What?
it'll have to be pretty big, won't it?
yeah, like 2 times. Yeah, that's a huge difference. Yeah. Why is it
Huh?
not
So
used
why
that
would you
way?
do that unnecessarily when you can do that with us with small with some small balls
Because we
that
heard
have a
about
lot of mass?
electromagnetism and magnetism, haven't we? And electromagnetism and magnetism is true to any kind of metal, by the way. If you look into it, even lead, even the metal lead is magnetic.
It's
What's
not.
up?
How do you know
Then I can.
that they are
What's
not
up? I can take you
attracted
to
to
the
each
woodshed.
other because of magnetism?
There's
What is
no
the cause for
magnetism.
What's the cause for
How do you
electromagnetism?
know
Tell
that?
it now.
How
What's the
do
cause
you
for
know that?
electromagnetism?
How do you know that if you never use
Because we
anything
have
else
instruments
for the
that test for
Cavendish
magnetism.
experiments besides a metal?
We have instruments that test for it for magnetic fields.
And on
Again.
magnetic fields, 1 second, have you done it to Cavendish just once in your life to see
Yeah,
how
it's cool, yeah.
the things
It
that
didn't
are
work.
moving? 1 second,
didn't work, by the way.
how the things are moving and are searching for a balance. When you have something that is magnetic, it's gonna stick. It's gonna stay there. It's not gonna move back.
Back who? Back where? Back to what?
No, so you're gonna have things that are looking for balance, yeah. When you imply magnetism, yeah, in gravity, the things are looking for balance. when you apply magnetic fields,
What?
they're gonna stick to the surface, my friend. You're not gonna have the same behavior
The surface of what?
of a metal to another metal.
Yeah, if it's magnetism, then those
No,
will
they're not
stick
gonna
together.
stick.
Exactly. Oh my God. So you don't know how the magnets are working.
Mate, if you would set up the Cavendish experiment in a way that is the same except for the two weights being wooden or plastic,
And
then that would be the
how much
one of the ways
Tesla
to prove that is certainly not about magnetism.
how much Tesla you need for a magnet to be attracted for, let's say, 1 meter apart?
How much? What do I need?
How much Teslas do you need?
Oh my fuck! I should know that from the top of my head, or what?
Because fucking hell, the
Yes.
gravitational fields are not working like the magnetic fields, mate.
No, they do not. How do you know?
No.
That? How do you know that?
Because you see the magnets behaving. Fucking hell, you can do experiments with your hands. From how much distance the magnets that are attracting or repelling.
Yeah, but by the way,
But by the way, what?
is also a mess, right?
I can take you.
I
I
just
can ask you the same questions about electromagnetism that you ask us about gravity, and you can't answer those. So is electromagnetism shit also? Like, what's the cause for electromagnetism? If it's charged, what's the cause for charge in particles? You can answer. Can't answer those.
Again, no, because you are deviating the topic that I started with, and then you were
You
deviating
deviated many times
from the other
already.
topic.
It's ironic.
I haven't. I haven't.
Yeah, you have. You ran off of disequilibrium. Started talking about theodolites. Then someone asked you about gravity. You left that again to theodolites.
No, we
Jumping
were
topic
talking
all the
about
time.
gravity for the past 15 minutes, so I didn't leave it. I mean, you can try to lie about it. Anybody listening in hears it. So
Yeah, you talk about disequilibrium, relative density, and said, no,
no,
I
you were
haven't
talking
talked about
about
that.
it. I was talking about the Cavendish experiment for the past 7 minutes. So
Yeah, now, but like 15 minutes ago, 20 minutes ago. It's all good.
don't
Can
live in
jump
the
up.
past, man. Don't live in the past. So,
So you have
the other
any
topic that I
cause for
brought up was
charge
the theodolites.
particles.
How do theodolites being used to measure the circumference of the Earth? Because that was the claim of Prof. Phil.
Is he here?
I'm not sure. No,
Who? What did you ask?
seemingly he is not.
What
Okay.
did you ask?
So you were assigned, right? You've just been assigned to me.
No,
Okay,
I did.
yeah.
I have. Oh my God! Do you think I'm paid? Yeah,
Interesting that the flat earthers think they own the
You
room.
have been
and
assigned.
They can make all the talking points. They own the room, so we can't talk about anything else.
Yeah. What was your question, mate?
How do you measure the
How do
circumference of the Earth with a
surveyors-
theodolite?
That's a good way. Yeah.
With the
That's good.
theodolites. So
Yeah.
in this century, do I have to measure it with the theodolites when I have, let's say, I don't know, I have ISAT-2 in the orbit? Do I really have to measure it with the theodolite?
Mate. Professor Phil or Prof. Phil brought down explicitly many times that surveyors measure the circumference of the Earth. No satellites. Okay, surveyors using theodolites.
You
And
can measure
ultimate.
it for you can measure it for a ground. It's not a problem. Yeah, you can measure it from the ground. But I'm telling you, I'm telling you, for extremely precise measurements, we have satellites. We are not bothered to measure
No.
extreme
That wasn't my question.
things.
Yeah, but Professor Phil isn't here.
So I will not get an answer. Great.
You can't get an answer from Professor Phil when he's not here.
And
He doesn't want to answer, as far as I'm concerned.
No, he's not here.
I have given you an answer about.
He is here, by the way.
Mate, I have given you an answer about
Oh,
bending
sorry,
of
I
light.
took your word for him not being here.
He
Sorry.
just ran away.
Yeah,
No,
he
I
ran
said
it away.
he's
Do you
doing
really
it.
think he ran it away from a stupid argument like that? How you gonna measure the
That's
Earth?
it. Now you are gonna insult some more. Great.
Oh, so do you think I am the El Capo di Tutti Capi?
One thing
Parla
you could do with
italiano.
the other light is measure the horizon drop.
Mio caro amico,
What does it
parla
measure?
italiano?
That's a very good thing. Like, what did you say?
You
The
can
theodolite
measure.
measures the
You can measure the drop of objects with the distance. That's one thing you could
drop
do.
of the objects.
Yeah, like if you get two
great,
mountain
so-
peaks at equal elevation, and you measure between those and see if the other one drops from the horizontal that you created with the theodolite.
What you see in the far, and you call it the horizon, is it the same as the horizontal plane that you set up with an auto level?
No, that's why I said that if you establish a horizontal plane from a mountain peak to another mountain peak, and the other mountain peak appears to be lower, even
Yes,
though
appears
you
to
created
be
a
lower.
horizon.
Great.
Yeah, I
Appears to
said
be
mountain
lower.
peak to mountain peak. Yeah, mountain peak to mountain peak.
So again, it appears
So
to
the
be
question
lower.
is, why are you asking about horizon now? What's up?
Yeah.
I'm asking if he knows that the horizon is physical
Why?
or apparent.
Why? Because
The
I said two
horizon's not
mountain
part of
peaks.
this.
Because in
Two
order
mountain
in order to measure anything regarding that, then both things have to be physical. That's why.
Yeah, a mountaintop is a physical thing.
And what you see about the mountaintop, is that physical?
Yeah, you
It's
see
like
another
he doesn't
mountain
know what
top.
horizontal means.
Yeah, two mountain
So it's
peaks.
not,
You measure from one mountain peak to another mountain peak. No
what do you
horizon.
measure?
You establish a horizontal plane, and you measure the
Mhm.
drop of the other mountain peak from that horizontal plane.
Yeah, because if it
You
was,
measure that
that
drop.
mountain peak was
How
higher, and
again?
you're taking a measurement to it. That mountain peak is always
Okay,
going to be
how do you
above the
measure
eye
that? That's
line.
my question for the fourth
sorry.
time.
What? How do I measure it?
Yeah.
I mean, I'm not a surveyor. I mean, Professor Phil might be better to answer you, but
Okay.
yeah, you can.
I
I mean, you
can
can
tell you how you
maybe you
measure the
can.
height difference between two mountains if you want. What's up?
Using a theodolite.
Yeah, using a theodolite.
The theodolite that shows you, because it's optical, of course, an apparent thing, right? That's
No.
what you're
So the
gonna measure.
mountain
Apparent
is
thing.
the mountain apparent?
The position of it is apparent.
Really?
Okay, so you can't measure
Yeah.
anything with a theodolite ever, and you can't
Not
establish
like
a
that.
horizontal plane,
Not
and you
over,
can't establish.
not over that kind of distance.
Is
Not
the
over that kind of distance.
is the measuring stick that you use, is that also apparent?
Well, man, what's the limitation on the distance? So how far could we use a theodolite to in your point?
100 meters.
100
100
meters?
meters.
Really?
No, but he's been
One
in.
second, man.
Yep.
Rabbit hole. So if it's 100 meters, why are we doing surveying over much longer distances than that?
No. You are doing it each by each. Every 100 meters you do it, and you go
You're
back
not
and
doing it every
forth.
100 meters. You don't know anything
Yes,
about surveying, do
you
you?
are.
No, he's been
Yes,
in
you are.
next level few days.
Differential leveling.
He's an
Differential
he's our
leveling,
best
right?
part.
Differential leveling, you can quite happily do. I've seen results number of professional surveyors over 1,200, 1,400, 1,500 feet. So 1,200 feet is about sort of 340 meters. 1,500 feet is about 480 meters.
And how do they do that?
With a theodolite.
Yeah.
And they do
From
it
one
to
point to
incredible
another.
degrees, and to incredible that's from station A to station B is the distance I'm talking about.
Yeah, and then they go to the station B and watch back towards station A,
Yeah,
right?
and they do that over a 400 to 500 meter distance.
So So they are not doing in a way that Molman just
No,
described.
I'm
They are
talking
not
about
just
reciprocal.
looking in one way and that's it.
No,
That's not
that's
it.
right. Yeah,
Okay.
I agree with that. You're dead right. We take
Okay.
observations, but that's if you're looking for reciprocal zenith angles. So that's kind of a different thing you're starting to look for then when you're measuring back. And the only reason you're measuring back is actually as a confirmation test. It's to collect more data points. You don't just take one measurement at station A, do you? You'll take a series of measurements at station A and then a series of measurements at station B, won't you?
Yeah, well, it has quite a short distance in which it's called
Yeah, but
correct.
I mean,
And,
we're talking
right?
about sort of what's classed as level 1 surveying. Do you understand that term?
Mate. So
So
we are not
you know
talking
you've got
about
level
miles
1.
here at all,
No, I'm asking, do you
right?
understand the term? If I say that's a level 1 surveying methodology, do you understand what I mean? I'm happy if you
Level
don't.
one.
It's not a problem. I'm not trying to do a gotcha. I'm just saying, do you understand? If I say that's a level 1 surveying methodology, do you understand what I mean?
Well, it means the best way we can do the measuring. Basically, that's what it means.
So yeah, that's where we're looking for extreme levels of accuracy. I mean, extreme levels of accuracy. So when we do things like
Down to
geodetic
the
surveying,
millimeter, right? Down to
yeah,
the hundreds
pretty
of
much.
millimeter. Yeah.
Well, I wouldn't say 100 a minute. We're talking about angles, so we're talking about arc seconds. And from that angle, that's how we can judge elevation change.
So again, no one uses in the surveying field a theodolite to look over miles and then describe anything
Oh
regarding what is measured.
no, they do.
Okay.
Again,
Okay.
that's
Great.
wrong. That's
They do?
that's done on level 3 style surveying. Which is again, and each of those surveying levels have a tolerance level that's associated to them. And level 3 surveying, the tolerance level for that is still less than the error bar for the curvature of the Earth. So it's still good for measuring curvature.
Hey, Emma.
Ah, yeah, they're listening in next level now. Hi, Bev. Hi, Emma.
Well, they are here.
No, I mean, I think if I go to next level, they are streaming this in their VC. Let's check.
Oh.
Oh,
do you
not
know?
today. Oh, it was like 3 days ago they did it, but not today. Sure. Yep.
How do you know that, by the way?
Even a level 3
Because
surveying
I'm in
methodology where you'll be
next
taking readings over thousands of, multiple thousands of feet, or, up to a sort of like a mile and a half, and even a bit longer in certain occasions, that's still accurate enough to measure Earth curve.
That's what they did when they did the triangulations from Finland to the
To
Black Sea.
measure Earth curve. Again, how do they do that?
Reciprocal zenith angles, the fact that plumb lines aren't parallel to each other.
And they use
The plumb
change to measure
are
distances
not
of
parallel to each other.
triangles. Yeah, they're not.
And when you look at when you plot that curvature, the differential between those zenith angles between plumb lines, and then you start to plot that out, we get a curve, and that curve is representative to the size of the Earth.
Okay, but how come they are not parallel to each other?
Because the Earth's
the plumb one.
curved. Yeah, because plumb is in the direction of gravity. Gravity is towards the center of the Earth. If the Earth was flat, then those plumb lines would be parallel to each other. They're not, because the Earth is curved, and therefore there is a differential in the angle.
Yeah, I get that. So the every vector at every point on the ground is is gonna give you a different angle.
Yeah, you can actually measure this. You can measure this in surveying distances of around 800 to 1600 feet.
So, sorry, if and this is a big if, but if we have a good measurement, we can do and we can show that the plumb lines are not parallel to each other even on a short distance, right?
Yeah, but as I say, about 600 to 800 feet, I think is about where you're getting towards that tolerance level.
So that's when it will show. That's the kind of measurement that we could do in order to prove that, right?
And it's been done. I mean, if you look at the Whitsick versus Main
That's what I'm
Surveyor
asking for.
on modern
Good.
day debates, Main Surveyor actually goes through his entire methodology in detail. It's one of the best explanations of how this.
I'm sorry, I have seen that.
Seen.
I only seen pictures that he drew.
And you saw the data that he took. You saw the photos of where his stations were set up.
No, I
You
have not
saw
seen that.
that's all in that
That's
video.
a
Then you
copy.
didn't watch all of it.
Yeah.
You didn't see the
Yeah, I
fact where he
have.
went into all his series of measurements and the standard deviation and showing his tolerance bars. Didn't you see that? Because that to me was incredibly impressive. Because not only is he saying, "Hey, I took these series of measurements, but I'm working out my deviation from the norm," which is what you do in engineering, because that's how you get to accuracy. I don't understand what your objection is here.
Does anybody have that video, maybe? Or what should I look for?
Modern day
YouTube.
debates, main surveyor. That'll get you it. Main, M-A-I-N-E, as in main.
I guess you can.
Thank you.
I guess you can just search for main surveyor and the original video about the measurements.
He explains it very, very well. Better than I
Oh,
can. You know, I've just done a lot of reading on the topic to try and understand what the subject is about.
Yeah.
And I've talked to some
So-
surveyors, like the main surveyor.
That video that is trying to prove that plumb bobs are not parallel to each other, is it on his channel?
Well, no, that's already been proven a long, long time ago. It's not him proving it. It's him repeating the same observation that has been many thousands and thousands, tens of thousands of times before. I can give you one book that's got 10,000 observations in it of this event, and that's the
But that's what I
triangulation of
asked
them.
for.
That's the plotting. That's the geodetic survey of North America and the arc of the parallel.
But that's what I asked for, because I said that
Cool,
all I
I'll
saw from
post
the
it
main
for you right
surveyor
now.
is a
Right now,
picture
I'll
that
post
he
that.
drew.
Here we go. I will post the data for you. Because
Thank
believe
you.
me, the one thing I have shitloads of, mate, is data.
Oh, wow. So you like this subject quite much. Okay.
No, I just think if I'm going to talk about something, I should be able to talk about it in some authority. And the only way you get that is by trying to understand a bit of the topic. When I started out talking about something, I knew square fuck all about it. But I listened to a lot of people, which gave me some basics, and then brushed up on a bit of my geometry, which I hadn't really thought about for 30 years. And then did some reading on surveying methodology. I went and looked at some course material for a number of colleges in the UK and how they teach it. And then I started looking at surveying results, and then I had better conversations with people who are actually surveyors, and then learned more from them, because now I could understand the reference points that they're making. You know, until we actually are speaking the same kind of language with the same sort of understanding of the principles involved, it's very, very difficult to get a topic like this across.
National Oceanic and Atmospheric Administration. Okay.
Mountain
They
Peak
have
to
the
Mountain
satellites
Peak.
that are admittedly not making a picture of the Earth as a whole, but only aerial photography.
Unless you look at
That's
things
great.
like Himawari 8 or Himawari 9, and then that is a picture of one side of the
We
Earth.
want to get into as complex a thing as possible to give them
So
as
we'll-
many as possible, many places to run to. We were on the Mountain Peak to Mountain Peak and measuring that, and he wiggled out of that with a parent, and everybody just let him off the hook on it.
Well, no, I think we dealt with the apparent, because he's now quite happy that, you know, we can measure this stuff over a distance.
Let's see what he
And
thinks
now he
about
wants to
that.
look at the data to say, okay, and you know, part of the reason I post this is it actually tells
What
me
does
the
he
distance
think
that's
about
within
that?
measures.
Does he agree with you, Dress?
I don't know. We should ask him.
No, because
Maybe we should let him answer.
Yeah, that wasn't discussed. I'm very trying to be very calm. I'm not trying to, attack people in any way. So my problem was at the very beginning when you were talking about theodolites and observations over long distances. You remember that I said that there is a certain distance in which the theodolites are supposedly working correctly and can give you great measurements. But after that certain distance, they cannot.
You're wrong. What's the distance limit on a
And,
telescope? What would you say the distance on a telescope limit is?
which telescope? Because I said theodolite. Not sure.
Which theodolite is 100 meters, and what's the longest distance a theodolite can be used for?
Theodolite. I think it's for an auto level, because I might have been wrong, by the way. I think the auto level was the one that is described to be able to measure things up to 100 meters, and the theodolite might be a little bit longer. It might be, you know, what who's the guy? Chemo's Bible guy said. It's like 300, 400 meters, but it's certainly not even a mile.
Oh no, but that's for level 1 surveying. I mean, that's where we're talking about ridiculous levels of accuracy. And that's
What else would I want to talk about? What else
What about
anybody
a bent
wants to talk
tube?
about when measuring stuff?
What about a bent tube with colored water in it? What's the distance limit on that?
The distance limit in what?
The bent tube of colored liquid in it that levels. You get the top and each side. It's shaped like a U. You bend the tube of liquid, and
Water
you sight
level.
up
Okay.
from the top of the liquid through the top of the liquid at the other end of this tube that's separated, and you look at what's the limit of distance on that.
Nothing. You can do
Okay, so when you're
whatever
standing on a
distance you
peak
want.
of X elevation, and you're looking into the distance at something else that is at that very same elevation, and you're not using a lens, you're using this type of level, this water level of sorts, and you're sighting up with that, and you can clearly see that the distant elevation that is at the same elevation as you is below level from where you are. That's horizontal. Horizontal is that level
How do
where
you
you
know
are projected into the distance, because we see it all the time. If you have not seen
How
it,
do you know it's
been hiding.
it's not just optics? It's not just
What?
refraction, and that's why it's below.
What was that word you just shut out?
I said refraction and optics.
Optics aside from your eyes? Are you not allowed to use your fucking eyes now, man?
Who said you're not allowed to? I didn't say
You're
that.
bitching about using your eyes now.
No, I'm not. I'm
Calling
telling
them
you
optics and
that
trying to dismiss the observation because you're using your eyes.
no, I have
And
not
what is
dismissed anything yet.
refraction going to do to your view? In this case, it's going to slightly raise that distant target in your field of view, which does not account for it being low. Why is it low if refraction's raising it up?
Well, that's your claim that refraction can only raise something in over long distance. That's just your claim.
No, not
never
can
seen that.
only, but almost always it's going to. This is the norm.
No.
Unless you get when do you get refraction dropping something in the distance, dude? What situations cause that? And how often do they occur? How prevalent is that versus the norm?
Okay, let me show you something. One moment.
So you don't have to be a scientist to make you look like the idiot that you are.
So now you are insulting me, great. Because as long as I have been here, I haven't insulted anybody.
I'm actually being a little bit too kind to you, considering the reality of
too
this.
kind. So by your normal, this is very kind. That's great. So what I'm showing you is the perspectival grid that any artist in the fucking world can use and knows already.
You don't even understand what you're
the
looking
more
at.
it converges to this center point of the view.
This does not explain what we're talking about.
This is the basic idea how things could look when we are looking at something.
And you don't understand it then,
comes in
because this is not what we're talking about. We're talking about you standing in that corridor, and you're at X height, and down at the end of that corridor, you got a target at the same height as you. and you looking through, say, an auto level at it, it is still going to be
now you're losing
at
using
that
the auto
same
level.
level. If it's at the same elevation as you, you're still going to see it there, despite your convergence.
Okay? So what is the claim in there? Because I didn't hear that.
You don't know what you're doing with this. You're
Ugly,
terribly confused, sir.
That's it.
Ugly Horse just did a demonstration of what Curve's talking about for your little optical corridor.
Yeah, and what is the explanation about that picture? Because I haven't heard that, or not even seeing any kind of explanation. Just a picture.
Objects at eye level stay at eye level when they recede into the distance, as long as they are the exact same height from where you're observing to where they're going.
Oh, so you are trying to describe reality with a picture without showing anything from reality. That's great.
Well,
You may as well be a sea lion.
Are you an idiot?
unfortunately for you, that's not reality, because what we actually see is that they drop from eye level. So, boom, wrong again.
And do you have any kind of picture about that happening?
And go look outside.
If I could be bothered to go and dig it out, what's up? I'll go and dig out the real photo that demonstrates what this picture is showing.
Thank you.
What that picture is showing is the fact that Blackpool Tower, which we see nicely above the much higher hills in the background, is taller than them from our perspective. Now, again, go up to Ugly Tiny Horse's picture. That would not happen if you're saying that the law's perspective work in the way that they should, the way we observe them. So anytime that we have an object that's taller, it should always loom above a shorter object in the foreground. Certainly if it's the same height as the especially if you're at the same height as the top of that object.
Let me show you my rebuttal to that in a moment.
Why does this guy think a picture should show reality and not just demonstrate it? That doesn't make any sense.
I think it's funny that you can look through a theodolite at 100 meters, and that is actually physical. But then when you go to 101 meters, that's suddenly apparent, and it shows you nothing about reality.
It's silly.
I never said anything like
got
that.
an increased margin of error as
I
you go
never
out further.
said anything like that.
So you can use a theodolite to 101 meters, and it's still actual and not apparent.
Not for measuring. That's what I said.
Yeah, you can use it for measuring, and when they use them over, so I just got them checked up, and you're right with the auto level side, that is generally used over shorter distances. But theodolites, we quite happily take measurements at 3 to 5 miles for height and elevation readings, and they're accurate, very accurate, because you're working on I think a 1 second angle of accuracy. So that's what, 1/600th of a degree?
Well, that's your claim, by the way. What is the measurements behind it?
It's not my claim, it's the claim of the manufacturers of the instruments.
The
So I don't know
manufacturers
why
of
you're
the
saying it's my
instruments,
claim.
they tell you not to use it, not to use, for example, an auto level over 100
we're talking
meters.
about a theodolite, so bring me a reference that says you should not use a theodolite over 100 meters. One, I'll take a reference now. I'll happily post the manufacturer statistics for you if you need me to do that, prove my point. But do you have anything that says you cannot use a theodolite over 100 meters to do this? Anywhere? I'm guessing that's a no then.
No, not from the top of my head, no. I cannot show you one.
Okay, so let's not make assertions about theodolites that we can't back up. Now, I can make an assertion because I've got the manufacturer specifications for it, which I'm happy to post. And in fact, I'll put up a nice reference here from this. This is normally a pretty good resource. Bit biased because it is the Encyclopedia Britannica.
Did anybody happen to mention that an object above an observer's altitude over a flat surface can never appear below their eye level due to perspective?
Yes.
Okay, good.
Yeah, parallel lines never cross.
All right.
At least to the perspective.
Well, I might have found something. Let me look at it.
Did anybody happen to mention a mountaintop being higher than an observer but being below eye level in the distance?
Yep.
And that kind of settles a not flat Earth right there.
Pretty much.
So, with a quite a quick search, I have found a manual. Or, let me be specific, for the ALAR 1050DD laser theodolite. And on page 8,
You're now talking about a different
it
instrument.
says the following.
You're now talking about a different instrument, by the way. What's up?
You're talking about the theodolite, am I not?
No, you're talking about something that uses laser range finding, laser sensors, and those have different limitations to an optical theodolite.
That's not a theodolite. What I'm
Not the
showing
laser
you right there,
rangefinder
the
on it.
manual for. That's not a theodolite that I'm showing you.
Not the laser rangefinder that's on it.
Sorry, mate, you're going to have to up your game if you want to play in the server. Yeah, you're looking at the distance on the. You're looking at the limitation of the laser for range finding. You're not looking at the limitation of the theodolite itself. So again, you tend to use laser theodolites in level 1, sometimes level 2 surveying, because again, you have quite a restriction in the accuracy that you can get because of the dispersion of the beam.
Okay. You're literally the first guy that I hear that you can use theodolites for whatever distance you want to measure anything.
I didn't say whatever distance. No. I quoted an accuracy level, which is an angle of arc of 1 second.
Yeah, I get that, but you say that even then you can use it.
That gives us our cone of accuracy going out, doesn't it? Yeah,
Again,
because obviously
even then you
our
say you
tolerance over
use it
distance, you know, our
calculate for the corrections. That's what you're claiming. I get that.
yeah. So, and all measurements fall within in some sort of like area. We never get an exact measurement for anything, do we?
Or we don't. That's
No, never.
fucking great then. Then how
No,
do you know
never.
it's a curvature at all if you come up with your
Because
even
of
corrected
tolerance.
calculations?
So let's say, for
Then how would you know that?
I know for a fact, I can tell you this categorically as a fact, that 1 inch is less than 1 mile.
Again,
Even if I've got a ruler, even if I've got a ruler that is, you know, half an inch out on accuracy.
If you claim that the theodolite is not really a good measuring tool because you just claim that it's not going to be precise,
I
then
didn't claim that.
what are we talking about measuring
I didn't claim
curvature
that it
at
wasn't
all?
accurate, and I didn't claim that it wasn't precise. I said you never get an exact measurement for anything. There is always a level of tolerance involved. Would you not agree to that?
Yeah, that's always the case. And your assumption is that even the tolerance correction, even with that, you can have an assumption that it's curved.
As long as the
what you get at the very end.
tolerance
That's fucked up.
lies within my error bar, then I'm good to go. Once my tolerance exceeds my error bar, then I'm not good to go.
And a tolerance of a couple arc seconds.
Basically, you cannot
is minutes.
determine.
You sound confused. What's up?
No, you confuse yourself, by the way.
It almost seems what's up is it almost seems like you're saying that unless you know something exactly, you can't say that you have any understanding of it.
Regarding measurements, yeah.
In that case, we don't know anything about anything. You cannot say that you know the distance to anywhere. You don't know the height of anything. You don't know the weight of anything. You know nothing about the measurements. If you need an exact measurement, then you don't have any.
It goes even further than that. He can't even be sure that his
that's a huge claim.
He can't even be sure that his left hand is his left hand if this is what he's really saying.
Do you understand the fact that if you don't accept, when let's take something simple that we all agree on. We all agree that combustion engines exist, and we have a cylinder inside.
Oh my fuck! Nobody's talking about combustion engines.
No. Trust me. I'm going to get to my point. Bear with me. So when we have that cylinder that we're putting into when we put the piston inside the cylinder, it has to be to a certain tolerance, doesn't it? It's not going to be exactly this measurement. It's got to be plus or minus X to work well with the car.
Yeah, again, no problem there. That's not what I said. What I said is that you think that your problems when you are measuring something that's not exact is actually curvature at the very end of your calculation.
No, because if we have, let's take, if we've made other observations that says the size of the Earth is about this, yeah, and then we go
size of the Earth.
The size of the Earth, the circumference of the Earth is about this, and we're saying it's a sphere. So we can have two propositions on the table. It's flat, with topography, and it's not curved in general, or it's curved with topography. And we've got
that's
an
how
idea
they do topography in the first place.
Yeah,
they
so
are triangulating.
those are the two options on the table. So then I can start to make observations. Now, one of those observations I make is that plumb lines go straight down to the Earth. We all kind of agree that we establish a horizontal from a plumb, a tangent from a plumb.
So we do. And what is the other horizontal? At the other place where we have another plumb line.
Exactly, and that's the point, because horizontal doesn't mean level, and that's I think a problem that you guys have with language.
So you have horizontals. You call them all horizontals, and they intersect each other.
But they don't intersect at 180 degrees. That's why we have a differentiation in the angle.
That's interesting.
Differentiation in the angle is way bigger than the accuracy level of the instrument.
Okay. So that means it's basically locally flat, right?
No. It means locally. No, because we see a difference in those two plumb lines. Those two lines don't meet.
It's not even locally flat.
No, of course it's curving from a millimeter away from your feet. It starts to curve because curves are just continuous.
Again,
we
it's
might
not
have some
even locally
topography
flat.
that changes that locally to us. So you're right. We could establish a flat bit of ground, a horizontal plane, if you want, in a local position. We can kind of do that. We do that with to a certain degree with foundations. But generally speaking, when we look at the Earth in general and look at something like water, we're going to see that curve because water isn't flat.
Again, so it's not even locally flat.
No,
it's not even locally flat.
It appears to be.
In fact, I would say that there's nowhere on my street outside that's flat. It's all curving in some way. Even the camber of the road is not flat.
Now, what you could safely say is that it's so big that human perception is not accurate enough to distinguish the difference.
Well, that's why they are using devices, tools, graded tools that are supposedly the best tools for measuring things like perpendiculars and horizontals and verticals.
Yeah, that's why we made tools to enhance our senses.
Yeah.
Yeah. Like it.
Measure
So
things
germ
better.
theory couldn't. Honestly, germ theory probably couldn't be a thing without the invention of the microscope. Because we had no cell theory couldn't be a thing without the cell theory couldn't be a thing without the invention of the microscope. Our senses just absolutely were not. Our senses were just not good enough to come up with to see that there are individual cells.
I think that germ theory predates the microscope, but the microscope basically proved germ theory. I think is the best way.
No, Leeuwenhoek invented the microscope in the 1500s. So I mean,
I thought they had the idea. I could be wrong.
It's not even locally flat. That's what I get from you guys. Which means
Correct.
that one end of a building, let me finish please, just one sentence. One end of a building, one wall that is supposedly vertical, and the other end, they are not parallel. That's fucking
Yeah,
great.
but this comes under a particular technical concept of measurement called the square root of fuck all difference. And when we're making a building, we're not getting accuracies to an arc second. We're not at like 90.000.
I thought you did.
Of a degree.
I thought that's what the devices are for.
We're pretty close to it, but it's not exact. And a building, a couple hundred feet long, say, it's going to make minimal. You're talking half a second of arc, 2 seconds of arc, maybe 2.5 seconds of arc, somewhere around that kind of figure.
There are way bigger buildings than that.
Tiny in that. Yeah, even way bigger buildings. So what you want to then do is say, what's the difference if I've got a wall at 89 degrees, 90 degrees, or 91 degrees to the effect on that building?
and you have to remember that that building, if you made it 69 miles long, the walls would only be a degree opposed.
And the degrees, the walls on the building are going to be 90 degrees. They're going to be set plumb, unless they're
They're going to be set plumb.
That they get tapered.
But they're not going to be parallel. Yeah. Great.
Yeah, and they're going to be deviating from parallel by, as was said, about the square root of fuck all.
Yeah.
Why do you think this is significant?
One of my problems was that you are calling all of the horizontals, and then you say that they intersect. Now that doesn't make any sense.
No, I said they don't intersect at 180 degrees. What's up? You need to listen to what I say. I'm normally quite precise with my language.
The reciprocal zenith angles of these. The reciprocal zenith angles of these are greater than 180 degrees, which means that the plumbs are not parallel, and the horizontals go in different angles for each other. So when they intersect, they create an angle that is not a continuation of a straight line. That's what he said.
Yeah.
He still doesn't understand what a horizontal is, I'll bet.
What's up? I've just posted a page on this from a textbook that might help you.
Yeah, that's called a tangent line on A, right? Point A.
Mm-hmm.
Great. But I don't get it, right? Because Jump understood it, so.
If you read the text, that's
we have a
also very
tangent line
helpful.
at point A. And then you have a level surface that is a circumference of a circle. What else do you have there?
Well, level just means that it's you're pointing towards the center of gravity.
I help you equidistant from the center of the Earth. That is one of the definitions for level.
Perfect. I like that. That was better than the way I put it.
Equidistant to a reference. It just happens to be center of the Earth here.
Oh,
now imagine me knowing better than you. That's quite interesting.
Well,
but I was just told that I'm stupid as fuck like that for the 10th time, by the way.
I felt that you were being a bit snowflakey early on because you thought people were being nasty to you. So
no, I haven't been a snowflake.
I'm trying to be extra nice to you, and then you use that to try and take advantage. Now, who's the piece of shit?
Sorry, this should be
what it gets you, John?
We are speaking.
That's why I don't waste my time being nice to these guys.
That was a pretty shitty thing to try and do. What's up? And I think you are better. I would like to think you are better than that. Sorry, I keep talking.
Again, this should be the normal. Not the way Jampanda and some others are talking to each other from time to time.
What are you talking about?
Well, I've been called like an idiot and a fucker like I don't know how many times so far, so.
Oh, by me, you haven't.
Yeah, typically when we start a
Okay.
conversation, we're cordial.
I suspect if you continue down this line, it will come.
Yeah.
But no, I mean, generally, most people here are pretty reasonable. The only time that we get annoyed is when people are being assholes, or I'm in a moody fucking mood because it's first thing in the morning. I haven't had a fact, and I do apologize generally for it later if I do go off.
No, it's actually happening way more than it should.
Well,
What's
if
your
you're a
problem
flat
with
earther,
horizontals intersecting?
no, go ahead.
But I'm not. By the way.
You're not a flat earther,
No.
right?
Does the Earth
Please
have
don't
curvature?
say the Earth. Yeah,
But you
please
know
don't
it's
say,
not a globe. Is that right?
I'm waiting for him to drop the Bev line, being like, it's not flat. It has hills and valleys.
Oh, why do you think I
If you
added the
proclaim that the
flat
Earth has-
topography code for the topography in, just in case?
Maybe he's a cone earther. Are you a cone earther?
No, he's a topographical planar.
And what is your problem
If you
with
claim that the Earth has
horizontals
no curvature, but
intersecting?
you are is actually a flat earther.
All right, we've done the bickering and name calling and stuff. What is your problem?
This is very interesting, by the way.
Horizontals
What you showed me.
bickering. I mean, God damn it! What is your problem? What's up with horizontals intersecting?
You shouldn't call them horizontals. If they are intersecting.
Why not?
Because horizontals in
Why not?
geometry are called the planes that are parallel to each other. That's why.
Whoa. Okay, but you're talking about 2D planar geometry.
It's also
That's
worth
a
mentioning.
presupposition, sir.
They're radials, like
It's also worth
spikes.
mentioning
No,
that horizontal is
talking
not
about
included
geometry.
in a geometric definition.
They're
No.
radials,
I said.
not
So I said
horizontal.
that the horizontals and the verticals are both parallel to each other. So when you say that there are
They're not, though.
horizontals which are not parallel to each other,
No.
then that shouldn't be called a horizontal. Neither
But
of
where
them.
do you get this from?
From geometry, Euclid's book.
Whoa. Okay, but you're only looking at planar geometry.
He gets it from Bev server.
You're gonna get something like that out of planar geometry only.
No, I'm not from Bev server, by the way. It's not. It doesn't work like
No
that.
one,
When
no
I
one
went into
fucking
Bev
talks about
servers, because I
Euclid
did.
except Bev. So.
I'm not gonna lie. Whatever you trying to paint of
You
me.
mean
I have gone
expand
to
your
the Bev
horizons?
server, and I told Bev that I did learn Euclid geometry. We just didn't call it Euclid's geometry because that's not how it's taught anymore, by the way. That is what I learned way before I came here or anything like that, was Euclid's geometry.
You've been given a source
Geometry
to
does
add
not
to your learning.
include
You
definitions
know more
for
about it now than
horizontal
what you knew
and vertical.
before. You know more about horizontals now. If you will look at
No,
that,
not about horizontals, by the way. No, that's
if
quite
you will look
niche
at what
cast.
Druss posted, yes, you should learn more about horizontals from that.
What did you post?
What it means to be you didn't even look at it. You were
What did you
were
post? I'm
talking to
not sure
Druss
if you
about
posted
it.
anything. Where did you post it? Because I'm looking at debate chat.
I
now.
didn't post it. I'm not Druss.
Ah, okay. So again, as I have learned, verticals are parallel to each other. Horizontals also are parallel to each other.
Only in that specific situation. You need to step out of your plane. You're not even in a box. You're trapped in an imaginary plane.
It's also worth
Or are
mentioning
you
that
trapped on a curve?
horizontal, oh my goodness, horizontal and vertical are not included in geometry. We don't say in geometry that things are horizontal and things are vertical, typically.
Yeah, it's because it's relational. It depends on your point of reference.
System, then. What the fuck?
That's why I said you can get that out of it.
Yeah. They also Euclid also talks about spherical geometry, which you seem to conveniently forget, especially when it relates to the fact that we're talking about a spherical Earth.
Oh, these guys had a field day on spherical geometry the other day. It was hilarious.
And that's what the surveyors are talking about. That's what that graphic was all about, that you talked about but didn't seem to see or didn't recall.
I think I'm bored, by the way. As fuck.
Usually when you're wrong and your arguments get destroyed, you get bored.
Yeah, it is boring
you get
getting wrecked,
angry.
isn't it?
No, you get angry when that happens.
Negative.
Are you angry?
So
No.
where do you plan to take your troll game next to get some excitement?
Troll game, so I'm now a flat earther, a troll gamer, what else? Like an
You
idiot?
said you weren't a flat
I
earther.
think you are.
You said you aren't a flat earther, right?
Yeah. Okay,
No, I
so
didn't.
let's get
Said I'm not.
what's up?
Like,
Could you please give us a position that we can understand you better by? If you're not a flat earther, you're not a globe earther. What are you?
No. I'm not playing that game.
Yeah,
You can find people
It's
who
not a-
would play you.
It's not a
that
game. It just
I'm
gives
not
us an
doing.
idea. It's not a game. It just gives us an idea of what your thoughts on the shape of the Earth are.
They need to put it on your file.
Why? Sorry, why are you so obsessed having a shape?
Well, either you
never
think
measure together.
either you think it's spherical or you think it's not spherical, and you're making arguments as if you think it's not spherical, but at the same time you're denying being a person who says it's not spherical. So that's a bit confusing.
No, I do not know the shape of the Earth. That's what I'm telling you.
Why are you arguing against it then?
Against what?
So
don't
you
know.
are a flat earther
Arguing
then.
against.
You should have just said.
That's no. I have not argued against the shape of the Earth whatsoever.
But you have. You've been saying that on a globe Earth, X and Y can't occur. You've been saying that.
I didn't say anything like that. That was you guys, not
Don't
me.
lie now.
You've given a list of things.
I guess he's
you've
trying to
given a
argue
list of
It
that.
was you guys, not me.
I guess he's
I
trying
have
to
no
argue that we
mention
can't know, isn't
the
he?
shape
But
of the
I
Earth.
don't think that that's true. I think we
That's
can
his
know.
thing. Is that we don't know anything. So since he doesn't know anything, we don't know anything.
Right.
Well,
He's proclaiming all horizontals are parallel, so by
It's
definition,
impossible to
that
know
is
anything about
mentioned
anything.
the shape of the Earth.
It's
If you're
impossible
not
to know
arguing
anything about
against-
anything. I got it. Yeah.
WhatsApp. If you're not arguing against the shape of the Earth, then why are we having a conversation with you? Like, where's this going? We all took geometry. We get it.
Well, that's why I said I'm bored, because I might just leave,
Okay,
because
then
it seems like you're
maybe
trying to
have a
label me.
Because you have no argument.
You're
That's why
trying
you
to lie about what I just said.
Maybe come
And
into our
in the
server
meanwhile,
with
you
a
were
firm
slandering.
grasp of a stance or a position that you can hold and then argue with, and then you won't be bored. How's that?
Again.
Yeah. So what's up?
Again,
If it is
you're
one of those
trying to
things where you're
label
saying that
me.
what's up? What's up? Okay, I'll skip the label, but I will tell you that you've come in and you've made a set of arguments that are very indicative of one side. And when the holes in your argument are pointed out, or the fact that you're wrong about the way that you're arguing something are pointed out, your response has been to say, "I'm getting bored now." That's a very weird thing to do.
That
You
wasn't
don't
the
seem to want to
response.
discuss
I
what.
have responded. No, I have responded to every argument you had.
Yes, and your response is now you're bored.
Yeah,
You
after
do,
nobody
you do
talks.
realize
that's
that all of
what
our
it is.
arguments are contrary to yours because we're framing it in the framework of we live on a sphere, right? So we're not arguing basic fucking 2D planar geometry with you. We all understand that. So if you're bored, then have a position. Otherwise, we're just talking about two different subjects. You're talking about fucking elementary math, and we're talking about the shape of the Earth.
No, again, the last thing that I wanted to hear, and I couldn't be sure about that, of course, if it would happen, is that if you think and if you want to label me with anything, and if you want to slander some more or not, well, it happened. So for today, I'm gone. Bye, guys.
That was
Better luck
fun.
next time.